All right, friends, it's your boy, Mr. Shagnon, coming at you with Unit 3, Lesson 2, corresponding parts and scale factors. Yesterday, we talked about the idea of a scaled copy. Scaled meaning that it can be the same size, an enlarged size, or a smaller size object that basically is multiplied by the same number to get the side lengths. Today, we're going to build on that definition with a few things. First, we're going to do a number talk, and it says find each product mentally, and these are multiplying by unit fractions. So this is a unit fraction, right? This is a whole number. So underneath every whole number or any number that doesn't have one, there's a 1. You're going to multiply 1 times 32, that's 32, over 4, and I'm going to show this process. That means 32, so once you get here, that's 32 divided by 4, which equals 8, right? If you wanted to do that in your head, you could. But the thing is that I'm trying to show you the process. This one, we're going to place a 1 here. And we're going to do 7 2/10 times 1. That's 7 2/10 over 9. This means 7 2/10 divided by 9. Now, some of you might get panicked here. But if you know your multiplication tables, you know that 9 goes into 72. So you know that it goes in 8 times. And so with this problem here is they're really testing your ability to think about numbers in that way. So if I know it's normally 8, if it's a whole number, then this is going to be 8/10 because 7 2/10 is less than 9/10. So if I multiply 8/10 by 9, I'm going to get 7 2/10. Right? In an ideal world, that's going to happen. But in this situation, right, we can do this. I want to show you the setup too. So if you don't believe me, and we can do it here. 9 goes here, decimal point here. 9 times what gives you can't do that. So 9 goes into this 8 times, so it gives me my 8/10. Like I said there. Underneath this one, you're going to place a 1. This is 5 6/10 over 4. For this problem, know that 4 does go into 56. If I know 12 times 8 is 48, plus another 4, that's 52. That's 13 times. So this is actually 14 times. It'd be a whole 14 if that was 56, but it's got a decimal point, so that's 1 4/10. If I'm going to check my work here, I'm doing 5 6/10 divided by 4. The decimal point goes up. This goes in 1 time. Subtract 4, left with 1, bring down my 6. That's 1 4/10. So we now have the money for that first activity. This is to show you remind you how to multiply fractions, because a fraction can be a scale factor, and so we need to understand how to multiply that by whole numbers or unit wholes to make that true. So in our next activity, we're going to be looking at some images and talk about corresponding parts. So this is us building on what we did yesterday. So the first activity was kind of a walk into using something that we're going to use today. This activity here says here's a figure and 2 copies, each with some points labeled. So here's the original, copy 1, copy 2. So complete this table to show corresponding parts in the 3 figures. Well, I'm looking at point P. If point P is here, in the copy 1, it should be F. So point F. And then in copy 2, it's point Z. So I'm looking at all the same places, right? So those are corresponding to each other. Corresponding means that they're identified at the same location in each drawing. Segment LM, so this is a segment. Segment is an edge, right? That's segment LM. So I'm going to look in the next one. I'm looking at BC. So I'm going to write segment BC. In this one here, I'm looking at segment VW. EF, so now it's going to change up on you. It's actually going to make you look at this one and look for the corresponding parts to this. So this is segment OP. And then this is segment YZ. Point W, so point W is over here. That would be point C. That is also point M in the first original. Angle KLM, so this is angle, so it's talking about angle KLM, so that is the angle measurement. So this is ABC, angle ABC, and then angle UVW. And then angle XYZ, so then our angle measurement is actually this angle here, right? So corresponding to that is DEF for the copy 1, angle DEF. And for the original is NOP, angle NOP. And then it says, is either copy a scale copy of the original figure? Explain your reasoning. Well, looking at this, right, I'm looking at this, copy 2 is distorted. It's stretched out. Using what we know from yesterday, we know that this is a distorted image, and so it's wider than normal. This one does look like the same shape. We don't necessarily know the side links, but it does look like the same shape, so I would say copy 1 is a scaled copy because it's the same shape and I apologize for that. Copy 1 is a scale copy because it's the same shape, just a smaller size. Right? So I'm going to leave that there for a second so that people can get caught up with that. So all we're doing is we're basically using the information that we learned yesterday because we're about to add something to that. That's what we're going to do in the next two questions. The next question says, use tracing paper to compare angle KLM with its corresponding angles in copy 1 and copy 2. So we're looking at KLM. So I'm going to look at some tracing paper here. So I have my tracing paper. I'm looking at this angle. So I'm going to trace this sort of thing here. And then what I'm going to do is I'm going to apply that, you know, as closely as I can. So that looks the same in copy 1. And in copy 2, notice in copy 2, it does not line up, right? So what do I notice about that? So what do you notice? Angle KLM and ABC have the same angle measure. Because basically when you take tracing paper and you overlay that, you can see that. So I want to put that there so that you can see that. Angle KLM and angle ABC have the same angle measure, and we're going to do that for, we're going to compare NOP with its corresponding copy 1 and copy 2. So we're going to do the same thing again. So NOP. So I'm going to do this here. So I'm going to trace the angle. So I'm going to trace the line segments, and then I'm going to take this and I'm going to try to match it up. So here you can see that it basically goes on top of that one, and then notice what happens here. So when we get here, it does not even cover the whole thing. So you can tell that it's not a scaled copy. So angle NOP, so what we're going to write here is angle NOP and angle that's angle NOP, so NOP and DEF and angle DEF have the same measure. What we've just identified is in scaled copies have to have the same side lengths, but they also have to have equal angles. Like their angles, their corresponding angles need to be equal to each other. They have to be the same measure. So we're adding that layer to our definition, right? So we're adding that to our definition. And so that's the big idea coming from this activity here. And our last thing is on scaled triangles. So it says here's a triangle O followed by a number of other triangles. So in class, you're going to be given a couple triangles to look at, but I want you to be able to take what you know, right, about angles and side lengths and see if these are scaled copies of each other. First, I'm going to look at my angle measure to eliminate some of these. I know that they have to have the same angle measure. Triangle A doesn't even have a right angle, so this is not a scaled copy. Not a scaled copy. I'm going to use that to my advantage. This one could be, so I'm going to come back to this. This one could be angle F. Not a scaled copy. I'm just using what I have, and the rest of them have a right angle. So I've gotten rid of 2 of them based off just one characteristic, which is having the right angle there. Now, look, we talked in our definition that a scaled copy can be the same, it can be enlarged, or it can be shortened. This is the same triangle. So this is a scaled copy. Scaled copy. Based off of our definition, that is the same exact triangle as that, therefore it's a scaled copy. Moving on over here, we have this triangle here, which has 3 to 2, 4 to 5. If this is decreasing and that's increasing, that makes 0 sense in the real world. So this is also increasing, so how could this be decreasing, increasing, increasing? So when you're looking at this, I'm saying from 4 to 5, that's an increase of something. But 3 is being decreased, and that shouldn't happen in scaling. So this is not a scaled copy. Right? Here, 2 is half of 4. Now if I basically do half of that, that does give me 2. If I cut 3 in half, it's still 3 halves. If I cut 5 in half, that's still 5 halves, right? And 5 halves would be 2 and a half, and this would be 1 and a half. So if you actually wrote them out, this would work. So this is a scaled copy. Scaled by 1/2. So it's half of the original figure. And E here, well, looks like it's double each one. So this is scaled by 2. F is not 1. And G here, we have 3 is 2. So then we have thirds. So if I take, remember, I want to compare the sides. So what I did in my class is I wrote 2 over 3. Would that give me the same thing if I wrote 8/3 over 4? It's a little bit more complicated, over 4. So we want to see if this will eventually give us, so we're actually going to have to do some math here. So 3 goes into 8 twice. So we have 2 2/3 divided by 4. 2 2/3 divided by 4. 2 2/3 divided by 4. So change this improper fraction here. So this is 6, 7, 8. 8 over 3 times 1/4. And this is 8 over 12, which does simplify to 2/3. So this is scaled by 2/3. 2 over 3. So that is a scaled one. This one is reduced by half. 3 is not reduced by half, so this is not a scaled copy. Not a scaled copy. So the hardest one was G, but G, remember, in order to see if it's multiplied by the same thing, one thing to do is do 2 over 3 and see if you multiply 4 by that, will you get 8/3? That's one way to check that one. The other ones do make a lot of sense using just reason logic. This table should be filled in with all the ones that are a scaled copy. So triangle B, its side lengths are 3, 4, 5. Triangle D is, you have 3 halves, 2, and then you have 5 halves. Triangle E, you have 6, 8, 10. And triangle G, you have 2, 8/3, and 10/3. So each one, right, if you look at the scaling of this to this is times 1. If you do this to this is divided by 2, or times 1/2. From this one to this one here, this is times 2. And then from this one to this one is this is times 2/3. Right, so that is what we're looking at tomorrow in class. I can't wait to see you and talk you through this tomorrow. Have a great day.